In the time it takes to brew a cup of coffee, a digital tidal wave is unleashed. Every single minute, a staggering 500 hours of new video content floods onto YouTube servers. To put that into perspective, if you were to sit down and watch just 1 minute's worth of these uploads, it would take you over 3 weeks, watching 24/7. Now, multiply that by every minute of every hour, and you arrive at a figure that's almost impossible to comprehend. Over 720,000 hours of video uploaded every single day. Think about your own videos. A single clip might be a gigabyte or two, but that's just one drop in an ever-expanding ocean. When you multiply that by billions of users, you're dealing with an astronomical amount of data. And it's not just one copy of your video. To ensure smooth playback, YouTube creates multiple versions of every upload, from low-resolution streams to crystal-clear 4K. Each version adds to the total, compounding the storage challenge exponentially. This leads to a question that has defined a generation of engineering. Where on earth does YouTube put it all? The answer isn't a single hard drive, but a global network of colossal hyper-secure buildings known as data centers. These are the physical heart of the digital world. Inside, endless corridors are lined with millions of servers, each one a powerful computer dedicated to storing, processing, and delivering this content to you in an instant. The scale is mind-boggling. We're talking about a daily data influx of roughly 4.3 petabytes. A petabyte is 1,000,000 gigabytes. To store just 1 day's worth of uploads, you'd need over 4,000 of the largest consumer hard drives. Let's make it even more tangible. A standard 1 terabyte external hard drive would be completely filled with new YouTube content every 20 seconds. Imagine a conveyor belt of hard drives, one filled every 20 seconds, 24/7. That's the relentless scale of YouTube's data challenge. The solution to this colossal storage problem begins inside Google's global network of data centers. These aren't just server rooms, they are hyper-efficient complexes, some larger than football stadiums. As the physical backbone of the digital world, they're strategically placed across the globe. Inside, millions of custom-designed servers hum in unison, managed by sophisticated software. This is where your video begins its new life, on a truly industrial scale. Your video isn't just saved to a single hard drive. That would be far too risky. Instead, it undergoes a process called sharding. It's sliced into smaller chunks of data. Each chunk is then copied multiple times. These copies are scattered across thousands of different servers, sometimes in entirely different data centers. This principle of redundancy is a digital safety net on a massive scale, ensuring no single point of failure can affect your content. So, if a hard drive fails, or a server goes offline, what happens to your video? Absolutely nothing. The system instantly detects the failure and pulls the data from one of its many duplicate copies elsewhere on the network. This self-healing infrastructure means your video is virtually indestructible, protected from the inevitable failures of physical hardware. But redundancy is only half the battle. The other key strategy is intelligent compression. Here's a secret. YouTube rarely stores your original file. Instead, your upload is transcoded, creating multiple, optimized versions at different resolutions, from 144p up to 4K. This ensures smooth playback for everyone by adapting automatically to your device and internet speed. It's the core of the seamless viewing experience we all expect, and a massive space saver. The effect on file size is dramatic. That 1.5 gigabyte 4K video you uploaded, the 1080p version most people watch might only be a few hundred megabytes. By creating these smaller, efficient files, YouTube saves an astronomical amount of storage. Now, multiply that saving by the hundreds of hours of video uploaded every minute. This incredible efficiency is what makes the entire platform sustainable. YouTube uses a content delivery network. Copies of videos are placed in servers all around the world. So when you watch, the video streams from the server closest to you. This saves massive amounts of bandwidth. YouTube never runs out of space because its storage is scalable. They just keep adding more servers. To understand YouTube, we first have to grapple with a number so large it almost loses meaning, the exabyte. YouTube stores not just one but multiple exabytes of data. So, what is 1 exabyte? It's 1 billion gigabytes. Still hard to picture? Imagine this. 1 exabyte is enough storage for over 34,000 years of non-stop HD video streaming. It's the equivalent of the entire Library of Congress, digitized 3,000 times over. It's a stack of DVDs that would reach far beyond the moon, and that's just exabyte. Current estimates suggest Google dedicates over 10 exabytes of its colossal infrastructure just for YouTube. This number isn't static, It's a tidal wave of data that's constantly swelling. Every single minute, over 500 hours of new video are uploaded to the platform. That means every second, another 8 hours of content finds its home in this digital universe. How is this even possible? It's easy to think of it as just a warehouse full of infinite hard drives, but the reality is far more complex and brilliant. Storing this much data presents monumental challenges. There's the sheer physical space, of course, but also the immense power required, enough to run a small city. Then there's the heat generated by millions of spinning disks, a thermal problem that requires industrial-scale cooling systems to prevent a catastrophic meltdown. It's not magic. It's genius engineering on a planetary scale. So the next time you upload a video, think about its incredible journey. The moment you hit upload, your file is whisked away, encoded, and then replicated across multiple geographically separate data centers. This ensures that no matter what happens, a power outage, a hardware failure, even a natural disaster, your video is safe and instantly accessible to anyone, anywhere. It's joining a global library, safeguarded by one of the most resilient and advanced storage systems humanity has ever conceived. But what does the future hold? With the explosion of AI-generated content on the horizon, will this system reach its breaking point? Can YouTube's infrastructure handle a 10-fold or even a 100-fold increase in uploads? Let us know what you think in the comments below.